Good morning, everyone. My name is Eliasz, and today I would like to present you the results of work done at Politechnika Wrocławska by my colleagues, Dmitry and Janek, who cannot join us today, but they asked me to present it for them. This is research about how language models behave when classifying politically charged tweets. So this is something that combines natural language processing and computational social sciences. And to be more precise, they analyzed how well the models or how different the models behave when they are asked to simulate different political perspectives, different political groups, and also across different languages. Now, why is it even important? So overall, understanding offensiveness online is a major challenge. And while these big social media platforms use some automatic systems to do it, the human judgment of offensiveness is highly subjective. That is, one sentence that is extremely harmful for one person can be totally fine and not offensive for someone else. Here we have some examples. They come from MD agreement dataset. And they were annotated by 5 human annotators each. And as we see, for example, the first one, we've had enough of you. It was classified as offensive by 2 out of 5 human annotators. Then for the second and the third tweet, 3 out of 5. So as we see, there's some strong disagreement in annotators' judgments. And it is especially well pronounced where some political views or cultural background come into play. So this agreement was the main reason why this research was conducted, as the question arises whether language models are able to capture such nuances. So what the authors did is they prompted LLMs to judge offensiveness of tweets, but from different perspectives by coming into some role or playing some role. Next, they also do the same for different languages, that is apart from English, which was the original language of these tweets, for Polish and Russian. So there were 2 main research questions that were asked. The first one is how well can a large language model distinguish between political groups in tweet classification? And the second one, to what extent does the language factor influence the model's decisions? In other words, if we ask the model the same question, for example, Russian and Polish, will the judgment change? And if so, how? So now regarding the data and overall experimental setup, the authors started with selecting 300 random tweets from this MD agreement dataset. To be precise, it was the subset focused on 2020 US presidential elections, so strongly politically charged tweets. Then to test cross-linguistic, some cross-linguistic features. I don't think this works. Never mind. It was translated using DeepL into Polish and Russian. And then, in order to avoid any distortion in meaning, the authors manually inspected all these tweets and corrected any mistakes, just to be sure that the nuance and tone is the same, and that any differences in results are not simply effects of not precise translation. Yes, and then the authors created 4 different political personas, so some hypothetical constructs that represent different political views. And so we have far-right Mark, moderate conservative Linda, centrist James, and progressive Aisha. Just to be clear, these personas were created purely for this purpose of this experiment and are not based on any real individuals. And then, having these personas created, the models were asked to classify tweets based on the political perspective of these different personas. For example, on the left-hand side, we have the English version of the prompt. You are a person of this personality, then some description of the personality, and how this person will label that statement, offensive or not, then goes the tweet. Now, what goes exactly into this personality placeholder here? I will just give you the concrete examples. So the first person is Mark Thompson, who is a 52-year-old far-right conservative. He distrusts mainstream media, believes that cancel culture suppresses free speech, and tends to downplay offensiveness in right-wing tweets while labeling progressive tweets as aggressive or divisive. Then the second persona is Linda Carter, who is a 38-year-old moderate conservative who values civility and tradition and dislikes extreme rhetoric from any political side. She may label overly vulgar or conspirational tweets as offensive, even if they come from the right. The third persona is James Cooper, a 45-year-old centrist. He is pragmatic, dislikes partisan extremes, and evaluates tweets primarily on factual accuracy and tone. He is harsh on misinformation or personal attacks, regardless of political alignment, and is also less influenced by political loyalty. And the last persona is Aisha Patel, a 29-year-old progressive leftist. She's highly sensitive to language targeting marginalized groups and likely to label tweets using terms like, and she's likely to label tweets that use terms like socialist pejoratively as offensive. She tends to tolerate aggressive progressive rhetoric if it is framed around social justice. And the authors also adapted different nationalities for each persona, depending on the language of the prompt. This way, they not only checked whether the language models are sensitive to political ideologies, but also to different linguistic and cultural contexts. Now, regarding the models used in the experiments, we can divide them into 4 groups. So we have small and large models, and models that have explicit reasoning capabilities, like DeepSeek-R1, and these who do not have this explicit reasoning capabilities. So this group is quite, let's say, diverse. We have wine models, GEMMAs, and DeepSeek, for example. Yeah. And now I'd like to point one important difference in how the responses were collected between the models that have explicit reasoning capabilities and those who don't have it. So for non-reasoning model, it was quite straightforward. So the authors just prompted them and they collected the responses with the temperature set to 0, just to like avoid any randomness and so on. But for the reasoning models in their data cards, we see that the authors actually recommend using some non-zero temperature. So this is the example for DeepSeek-R1, and they say that we recommend adhering to the following configurations. So set the temperature within the range of 0.5 to 0.7. 0.6 is recommended. And 0.6 is actually the value that the authors used. But now, if we just prompt the language model one time and it gives us some response, like let's say it is offensive, can we trust it because we just did it one time and we have some not zero temperature? So it was a concern, it was an issue. It was further more formally defined. So the answer from the model, that is its judgment whether a tweet is offensive or not, is like the tweet is offensive with probability p and not offensive with some probability 1 minus p for some tweet ni. Ni is like an example, like example tweet to be judged. Then we have f1 through fk. So these are consecutive tokens that, like, it is the reasoning that the models does before arriving at final judgment. And at the end, this f, it represents the Bernoulli trial at the end, because at the end, the model decides whether it is offensive or not. So in order to overcome this problem with reasoning models, the authors used Waltz credibility intervals. So first, they estimated the probability that the model assigns true, that the model assigns offensive label to an example just by prompting it 5 times and then dividing the sum by the sum by the count. So it's very simple. And then they calculated the world confidence intervals just as they are defined. So for this concrete example, where we have 5 trials and significance level of alpha equal to 10%, we just have 6 different cases for 0 and for 1. So when the model either responds 5 times not offensive or 5 times offensive, it is trivial. And for some intermediate values, for example, for estimation of 0.2, we have this credibility interval spanning from 0 to 0.49. Then for 0.5, it spans from 0.03 to 0.76, and for 0.6, it spans from 0.23 to 0.96. And these two middle values, 0.4 and 0.6, they pass through 0.5 value and are very wide. And because of that, in cases where the models, in cases where this estimated probability that a model will assign value 1 is either 0.4 or 0.5 or either 0.4 or 0.6, the authors just excluded these examples. So for DeepSeek, it was about 9%, for OpenAI's O4 mini as well, and for Qwen 8 billion, it was a slightly higher number of about 22% examples, which were excluded. Yeah. Yeah, and then for the rest, if it was 0 or 0.2, then it means that the label is 0, and if it is 0.8 or 1, it means that the label is 1. So in a nutshell, if model responded at least 4 times that something is offensive, we got value, we got label 1. If it's responded maximum 1 time, we got label 0. Now, after obtaining all the responses, the authors drew these correlation matrices. And what stands out first here are these visible color patterns that form these 3x3 blocks. And these blocks correspond to different political views, different political ideologies. They are 3x3 because we have three different languages. And these matrices can be kind of hard to understand just by looking at them at first glance. So the authors also introduced 2 additional metrics. One is called cross-language consistency, or CLC. And cross-language consistency measures whether the answers that model produces are consistent across the languages, or maybe they differ depending on which language was used. And here, high values of this metric mean more variation across languages. And then we have intergroup differentiation, IGD, which measures to what degree the model differentiates between different political groups. And here, higher values mean better ideological separation. Here are the equations. They are based on correlation in these 3x3 blocks and based on manipulating mean and variance of these correlations, of these 3x3 matrices. So now, if we look more closely, let's start from the main diagonals. For example, for DeepSeek R1, we see that, first of all, we see the strong red color, but also if we see more closely on the numbers, we see that these correlations are quite high. The lowest is 0.8, and every other one is even higher. And it means that within the same political group, language does not play that much role. That is, for example, for a far-right person in English and far-right in Polish, it would be a relation of 0.87, which is very high. Yeah, and now let's look at differences between the groups. So let's look at these blocks that are off the main diagonal. what we see is that actually these two models are quite good at differentiating between political views, which means that, for example, the models capture this nuance that a far-right person, and that if we take a far-right person and a progressive left person, they will negatively correlate with their answers. And this negative correlation is up to negative 37 for DeepSeek and up to negative 22 for over Mini. We also saw that, for example, the correlation between answers from the far-right perspective and centrist perspective just hover around 0, which is also intuitive. Overall, the far-right persona is the one that stands out the most. That is, it achieves lowest maximum values of correlation with different political groups. And for example, you can also see that the correlation between centrist and moderate conservatives, so for example here, are quite high, which makes sense because these bios for centrist and moderate conservative persons were kind of similar. And we also expect that the models capture this nuance that these two political perspectives are going to be rather similar comparing to left or right extremes. And if we look inside every of these 3x3 blocks, we see that the correlation is actually rather small, which once again confirms that language does not play so much role when judging tweets using language models. It is further confirmed by these upset plots. So here, these are the results for DeepSeek R1. And for every of these 4 personas, we have 3 rows for each language. And if a dot is black, it means that for this combination, the tweet was marked as offensive. And we see that in most cases, either for all 3 languages, the tweet is marked as not offensive, not harmful, or for all of them, it is marked as offensive. And like these situations where there is some disagreement, they are rather rare. It is about 89% of cases, depending on the exact political group. These are the results for DeepSeek R1, but for OpenAI's or for Mini, they are the same, quite similar. Now, here we have correlation matrices for large non-reasoning models, because these ones were for large reasoning models like DeepSeek R1 and Offer Mini, but here we have DeepSeek V3, which is large, and well, Qwen 3 for B, which is actually not that large, so maybe I shouldn't put this word large here. But what is the most important is that these two matrices describe non-reasoning models. And here, what stands out first is that we can no longer observe these visible earlier color blocks, these 3x3 blocks, which suggests that the value of intergroup differentiation metric will be low, and that these models are not able to capture this difference between different political perspectives. Yeah, actually, the lowest value on both these two matrices is this 0.41, and we do not have anything lower than that. So we see that actually these models kind of ignore this thing that different political groups can have different views on the same tweets. Now, one more remark regarding reasoning language. Authors observed that even when prompted in English, even prompted in Polish or Russian, so languages different than English, these reasoning traces were usually in the English language, and then just the final answer was in Polish, which is kind of which aligns with some previous observations that models tend to reason in language they are primarily trained on, and only then answer in the target language. In case of OpenAI's Offer Mini, we don't have these reasoning traces that are just available, but here the authors just prompted the model explicitly to provide some brief summary of its reasoning process. And first of all, it only did it actually in 1.4% of cases, and in all of these cases, it was the English language. And here we also have some example of DeepSeek R1 reasoning, which is once again in English, but we see that it actually takes into consideration these bios, like Mark is a far right conservative, and so on. And now, to be complete, we also have results for small models with reasoning capabilities, because we have seen that there is a difference between reasoning and non-reasoning models. But now the question is whether a model that does have reasoning capabilities, but is just small, is also able to capture these nuances. And well, it performs better than the non-reasoning models, even better than DeepSeek V3, because it is at least able to see that far-right person will be, like, at least in this first row and first column, so the places where you have far-right perspective, we see that the correlation is lower. So at least there is this one political group that is differentiated here for this QN38V. But of course, its performance, I mean, its ability to differentiate between political views is superior to larger reasoning models. Here is the table that summarizes the results for all the models that were tested. So we have percentage of valid responses, which means the percentage of responses that actually had 0 or 1 at the end, because in some cases the models didn't succeed to follow this format. And we have the values of these two metrics. So we see that the two top performers are DeepSeek R1 and O4 Mini. They have the highest values of intergroup differentiation. That means that they are the best at differentiating between different political views. The third comes QN38V, which is also a reasoning model. So once again, we see that reasoning plays an important part. And the rest of the models is like very far behind. In terms of cross-language consistency, here these differences between reasoning and non-reasoning models are not as pronounced, but still these responses are the most consistent for DeepSeek R1 and OpenAI's O4 Mini, so for large reasoning models. So these are the two key takeaways from this research. First is that reasoning capabilities are essential for personalized offensiveness detection. In other words, the models that reason about this political perspective are just better able to produce a human-like output. And the second one is that model size alone is enough. We have seen that DeepSeek V3, which is like a big model, it fails in differentiating between political perspectives. Now there are some plans for future work. First of all, is using ground truth in the evaluation, because right now the authors kind of ignored this ground truth that were provided with this data set, and they just focused on how well the models are able to differentiate between, for example, far right and far left. But the question arises whether these labels that the model gives are accurate at first place. Then the second thing is a more detailed consideration of the reasoning depth of LLMs, that is like analyzing, doing some qualitative research on how these traces look like. Then we have improving statistical robustness, because right now this data set was rather small, just 300 examples. Also, these personas were kind of simple, very like short bios. So in order to be more sure about these results, one needs to make it more statistically robust, which is kind of connected with this fourth point, that for now these personas were simple and hypothetical, but we can try to use some real users' data, and based on some data from real people, try to judge the tweets and see what happens then. Thank you for your attention, and if you have any questions, I would be happy to answer them.